This is the review for Unit 6B, and the first thing we're going to do is label the triangle below to show that they are similar. It says similar, not congruent. So angle C needs to match with angle F. C needs to match with F. The markings that you use don't have to be the same as the markings I use. E matches with H. But you do want to use different markings from C to E to show that they may not be the same measurement. And D to G, D with G. Here we have showed all angles match because when they're similar, all angles match. But if you just marked two angles, that also implies similar. So either one of those is fine. The two triangles are congruent by what statement? You have a side, two sides matching with the other triangle, but you also have here in the middle vertical angles. So you have side, angle, side, side, angle, side on both of these. Side, angle, side. And ABC is congruent too. So if we look at these markings a little bit closer, A has the one line and so does E. So A matches with E, B matches with D, and then C at the end. So EDC matches ABC. What's the definition of a circle? A circle is points that are all, so we should say infinitely many points. Infinitely many points that are all equal distant from the center. What statement is needed? We're missing a piece of information. So we have an angle here and we have a side. We have an angle and a side. That means we have a side and an angle. We're missing a side, and it needs to go in that order. SAS. So side, angle, side. So we're missing the other side, and they need to be in the order. If I put the S over here, notice it's now AS as I go around. And you can't go around this way because then you're skipping a bunch of stuff. You have to go to the next closest marking. So in this case, we would say that the side has to be, you got angle side, we need the other side to be here. So that's, and same here, we've got side, angle, side, so that it's in that order. That means JI side needs to be congruent with side TS. And in this case, it does not matter which way you write those letters. It could be IJ and ST. Either way is the same. Here you've got a side and an angle, and we are missing a angle. We got a side and an angle. We need an angle. So it needs to be in that order. AS. Therefore, the other angle needs to be up here, so it's ASA. And we need angle L to be congruent to. If you use three letters, that's fine. You could say MLK. And then over here, you've got angle side. We need angle here, so it's ASA. That would be angle T. Or you could also write it as angle STU would also be the same thing. Solve for x, it's a decimal or a fraction. So we would say 11 compares to 7 as I can't really read those numbers. I need my paper. Yeah, 15. It is a 15. 15 compares to 15 plus x. So we're going to cross multiply. 7 times 15 gives you 165. And if you multiply these two, you're going to have to distribute the 11. So you'll get 105 plus 11 times x is 11x. So we solve, subtract 105, subtract 105. You get 60. 60 equals 11x. Divide 11, divide 11. 7. Where am I? Hold on. 11 compares to 7. Oh, I set this up wrong. Don't listen to what I say. Reverse. Okay, sorry. 11 compares to 7 as this compares to this. You got it? I went big to small, so it's got to start with big again. So 15 plus x over 15. Sorry. 11 times 15 is 165. And we're distributing the 7. So we get 105 plus 7x. Subtract 105, subtract 105. We get 60 equals 7x. Divide 7, divide 7. So if you got the decimal, it's about 8.57. If you want the whole exact answer, you would say x is equal to 60 over 7. Triangles below are similar, congruent, or neither. You've got angle, side, side, angle, side, side. They are neither. Angle, side, side is not going to work. It doesn't, similar, you have to have angle, angle at least, and congruent, you can't have ASS. The two triangles are congruent by what statement? Number 8, you got angle, side, and here in the middle, we do have this other angle that we can say because they're vertical angles, so it's angle, side, angle. Number 9, two congruents are similar. You have angle, they share a side, and then you have angle, they share a side and angle. Angle, side, angle again for number 9. Number 10, 5 compares to 15. I'm going to set it up right this time. So small to big, 4 compares to D. Cross multiply, 60. 4 times 15 is 60. 5 times D is 5D. Divide out the 5. So D is equal to 12. Over here, the perimeter of the triangle with the vertices. You got 0, 4, which is right here, 0, 1, and negative 4, 4. Here's our triangle. This is 3, 4, and we're going to find this using Pythagorean theorem. 3 squared plus 4 squared equals c squared. 3 times 3 is 9. 4 times 4 is 16. Add, you get 25. And to get rid of the squaring, you have to square root. You square root both sides, so the c comes out. So c is equal to, what times what is 25 times itself is 5. 5 times 5 is 25. That is not what we were asked, but we do need that to get the perimeter. Perimeter is add all 3 sides together. So 3 plus 4 is 7, plus 5 more. So our final answer should be 12 units. In this case, it doesn't give us centimeters or inches. So we've just, perimeter is 12. Classify the triangle formed. You got negative 1, 0, negative 4, and negative 1, 3. This side length here is 3. This side length is 3. We don't know what this side is, and just to be sure that they're not all the same, we could actually find it. I'll tell you right now it's not the same, but let's make sure. You got 9 plus 9, and you got 18. If you square root 18, you get about 4 point something something. I don't really know what it is. But that proves that that last side is not the same. We do know that we have this 90-degree angle here. So it's a right triangle, and we also know that if two sides are the same, equilateral means three sides the same, scalene means 0, and isosceles is 2. So this is an isosceles. For number 13, we're going to copy the segment. So we have to have something to copy onto. So the first thing you need to do to copy is to draw another line segment anywhere. Actually, you could just start with a point. You don't need a full line segment. Let's just start with a point. Change my mind. Let's get rid of this. Delete. Okay. So we're going to start with a point. It can be anywhere. And I need this compass over here. So we're going to move our compass onto the point. If I can do this correctly. And from here, you're going to swing your arc through. Okay, and then you're going to take your compass, drop it down on the other point, keep that same measurement, and you're going to swing your arc again, that same arc. So if it's the same arc and you use your straight edge, you can connect it to any point on that, because you know that these must be the same length if you use the same radius. So I'd call this A prime, B prime. Next, I don't need this for these ones. Name the shape below. Here we've got a pentagon. The lines of symmetry, it says how many are there and draw them. So I know a pentagon has 5 lines of symmetry. And if I draw them in here, 1, 2, 3, 4, 5. And last of all, list the degrees of rotation. So I do 360 divided by 5 and I get 72. That's the first degree rotation to put it back onto itself. And then you just keep adding 72 multiples, or just keep adding 72 until you get back to 360. So 144, 216, 288, and 360. All of those degrees will put that shape back right on to itself, exactly what it looks like now. Here we've got a hexagon, 6 sides. It's got 1, 2, 3, 4, 5, 6 lines of symmetry. It's supposed to go through that point right there. So 6 lines of symmetry. And again, we do 360 divided by 6 and get 60 degrees. So we have multiples of 60 degrees. 60, 120, 180, 240, 300, and 360. We've got a heptagon here. Heptagon. And you have 1, 2, 3, 4, 5, 6, 7. So there should be 7 lines of symmetry, and then 360 divided by 7 is not an exact number, so we're going to say it's about 51.43. So if we keep adding that number onto itself, then our lines of symmetry are about 51.43, 102.86, 154.29, 205.71, 308.57, and then 360. Last of all, the last one on this page, I actually need a new page I'm going to go to. Here on this side, you've got an octagon. It's 8 sides. Octagon. It's got 8 lines of symmetry. is the same as how many sides it has. So you got 1, 2, 3,